actually. So we're going to be dealing with this unit. Technically, this is 4-1 because technically we have done unit 1, 2, and 3 because remember how we had to combine unit 2 and 3, everybody, and make it one test? So I just called it all unit 2. So we're technically on 4-1 if you want to title that. Your worksheet's the white one with the blue paper stapled. And then notice you have a note paper. Okay, I'm only going to use this here and there. It just depends based on what some of the other teachers use. So if you'll flip to the second page, notice it says Unit 4, 4-1 notes. We're only going to use a few things on there. And then I like to work off of your worksheet a little bit so that you don't have so much homework, if that makes sense. So we will do some things off of that as well, though. Okay, so today we're starting the unit of rationals. So first of all, this is 4-1, and we're going to be simplifying rational expressions. So rational means can be written as a fraction. So here are some examples of some rationals in different forms. So 1/3 is a rational because do you see how it's a fraction, everybody? A rational is a fraction. This is also a fraction, but this is a fractional expression. That's what we're going to be dealing with. Expression means it's just something with x, an unknown, but it doesn't have an equal sign. Does everybody understand? So we have x plus 2/3. That's considered a rational expression. Today we're going to be simplifying those. So I just want to start out with something basic and show you, you know how to simplify something like this. And I'm going to show you the math of how you're actually simplifying it. We just see, oh, they both divide by 3, which is what we're doing. But this is technically what we're doing mathematically. So with something as simple as this, technically what we're doing is we're factoring it out. So if we factor out, factor means what multiplies to be something. So on top 3 is just 3. But on bottom isn't 27 9 times 3, everybody? So do you see how I factored this? Now understand, I haven't factored it completely because you see how 9 can break down into 3 and 3. So this is getting really technical, but I'm just showing you, and this is going to help make sense of what we're going to do later. So 9 is the same thing as 3 times 3, and then we still have that 3. Does everybody see how we really just have this? We factored it completely, so what you're doing mathematically when you simplify this is you're dividing out exact factors. We have a 3 on top, don't we have a 3 on bottom? Those divide out to become 1s, correct? So what's left on top? 1, and on bottom, we have a 1 times 3, which is 9. Now, we would have seen that much quicker. We just say they both divide by 3. That becomes a 1/9. But technically, this is the math of what's happening here. That's what we're going to be doing with rational expressions. Factoring, dividing out exact factors, just like we always have been doing. So if we saw something like this is considered a rational. This is a rational expression because it has an x. So let's factor this. On top, we have 3 times x. That's not connected by anything other than multiplication, right, everybody? And then on bottom, we just did this. 27 is 3 times 3 times 3, correct? And then we have times x. So now we can divide out exact factors, just like we did in the previous example. 3/3 becomes 1/1. X over x becomes 1/1, correct? And now left on top is 1 times 1, which is 1. And left on bottom is 1 times 3 times 3 times 1, which is 9, correct? All right, so you guys see how this is kind of working a little bit. Okay, awesome. So this is where we have a lot of common errors come in secondary math 3, is people do things that are completely forbidden. They break a lot of rules that you can't do algebraically. I'm going to try to hopefully make sense of why you can't do them so that you understand why you can't do it. And that will help you not make the errors. So when simplified rationals, we can divide out exact, notice I underlined exact factors only. So rule of thumb, like a rule of thumb I use is this. If it's being multiplied, you can divide it. If it's connected by multiplication, it's okay to divide something on top and bottom. Does that make sense? So there's 2 things multiplied on top, it's okay to divide them out, the top and bottom. Does that make sense, everybody? But if it has an addition sign or subtraction sign, it is connected. It is connected with an addition sign or subtraction sign. You cannot divide it out with something on bottom. Unless there's that exact thing on bottom. So does everybody kind of understand? We're going to look at some examples here of what I'm talking about. So everybody, let's look at this first example right here. We have 3 times x. Multiplication, so we can divide out 3 with something on bottom. We can divide x with something on bottom. Does everybody understand? Now we have a 6 times x squared, so it's times, so we can divide these out. They're not connected by anything other than multiplication, so we can divide out. Does everybody understand? So this is simplified to be 3 simplifies to be 1 over 2. X over x squared is x where though? On bottom. This becomes a 1 over x, correct, everybody? So on top we have a 1 times 1 left, which is 1, and on bottom we have 2 times x, which is 2x. Does everybody understand? So that one we could simplify. Now looking at this one, we have 2 times x minus 2. So this times means we can simplify 2 with something on bottom, and we can simplify x minus 2 with something on bottom. But guess what? You see the subtraction sign? That is connected. It is absolutely connected. Did you all hear that? So the only way you could take and divide out x minus 2 or anything to do with x or 2 is if there's that exact x minus 2 on bottom. Does everybody understand? So we can divide out 2 and 4 because it's multiplication here. That would become 1 over 2, correct? There's x minus 2 on top, or 2 on bottom. Didn't I just say that that's connected with subtraction? So we can't divide out. Does everybody see? A lot of common errors that say, oh, 2's divide out. Can't do that. Does everybody understand? Has to be x minus 2. Okay, awesome. So that simplified to be x minus 2 over 2. And then we just talked about that. Okay, so looking at this one, we have x minus 2. Oh, where'd my little page extender go? I gotta get that up. Knowing that rule, while I get my page extender up, can I simplify the bottom 3? Guys, shout out to me. Tell me, what did you decide? Yes on the first one or no on the first one? Yes. So what did you divide out? X minus 2, there's an x minus 2 on bottom. That exact thing on top and bottom, they're connected with subtraction, but those exact things are on top and bottom, so you could divide them out. So what'd you get? Good. I'm glad you said 1/2, not 2. Okay, awesome. Can you divide this one out? No, right? This is 2 minus z. It's connected with the subtraction sign. No dividing out unless that exact thing is on bottom. A lot of common errors is z over z is gone. Does everybody understand? Very good. How about this one? Isn't it x minus 2? No, right? X minus 4 is connected with a subtraction sign. That exact thing has to be on bottom. There's nothing more we can do here. Does everybody understand? We're not going to make common errors. Here we go. All right, so looking at this one, let's go ahead and divide out what we can. Now, here's the trick. To know if you have exact factors, you have to have it all factored. You can't have it in non-factored form and say, okay, there's nothing that divides out here because 2x minus 2, there's not a 2x minus 2 on bottom. There are exact factors, but they're just in disguise. So we have to factor it out, and then we'll see if there's exact factors. So on top, what do we factor out? Guys, it's pretty straightforward. What do we factor out? What's in common? A 2. So we'll pull out a 2, divide by 2. So what's left inside? X minus 1. Okay, we factor to the top. Sorry, I have a cough, and so my throat is so dry. And then on the bottom, we have a 4 and an x minus 1. Okay, now let's divide out what we can. Multiplication means you can divide it. So right there's multiplication. So 2 over 4 becomes 1 over 2. X minus 1 over x minus 1 becomes 1 over 1. So this simplified to be 1/2. Is everybody good with that? Okay, one last thing, then we'll just start practicing. This is literally the last thing we're learning today, and then we're just going to practice. So the most important thing is because we are dealing with an expression, expressions have x values or unknowns. There is a time when we have to restrict our domain or restrict what we put in because domain is input. If you put something into a function, don't you get something out, everybody? Right? So if I plugged in -1, we'll get something out, correct, everybody? Do we all understand that? So we've got to restrict what we can put in. Here's why. You can never divide by 0. So your denominator, the bottom of your fraction, can never be 0. If you even try, let's all do it for fun. Pull out your calculator, type in 2 divided by 0. It will say error, correct? 2 divided by 0, because we can't divide by 0. You just can't divide by 0. We can get into the math behind why, but it just will blow your mind. So everybody understand, you can't divide by 0. That's undefined. Your function is undefined at 0 when you divide by 0. So does everybody understand that it is not okay for the bottom to be 0? It is, however, okay for the top to be 0. 0 divided by 2 is 0, but 2 divided by 0 is not okay. Does everybody understand? It's undefined. Okay, so we've got to look at this polynomial or this expression and say, when would the bottom equal 0? So wouldn't it just be to say, when does this equal 0? You guys think about how would we algebraically solve for that? Wouldn't you say, When does x plus 2 equal 0 and solve for x? So what would we do? Minus 2, so x equals negative 2. So if I plug in negative 2, won't that make the bottom 0? That is the only problem. I can plug in any other real number here, and it's okay. Does everybody understand? So we would have to say, okay, x cannot equal negative 2 for this particular expression. Does everybody understand? That's going to be our domain restrictions. That's going to be part of our answer. Is everybody good with that? Okay. All right, so our excluded values, that's our excluded value right there. So we would then simplify this after we exclude our values, but this one didn't simplify. So we would just say this is our answer as long as x does not equal negative 2. Because if it did, then we would have an undefined expression. All right, so looking at this one, we've got to exclude our values. Now you've got to, here's the trick. You've got to exclude your values before you divide anything out. Did you all hear that? Because we're going to be plugging things into the original function, not the simplified function, and we're not even going to be plugging things in, but that's where you would plug something in. So looking at this one, do you see how the x's will divide out? That's great and dandy, but you first need to restrict the domain, meaning restrict what we can put in. So look at the bottom. When would this bottom equal 0? Aren't there two factors? Don't we solve, that's technically quadratic, but don't we solve things like this that are linear factors by setting each of them equal to 0? So when we have x equals 0 and x plus 1 equals 0. So solve for x. X cannot equal 0, which makes sense. 0 times anything is 0, correct? And then wouldn't we solve for x here? So minus 1. So x cannot equal negative 1. So we're saying x cannot equal 0 and x cannot equal negative 1. Why? Because that would make the bottom 0. Does everybody see it? Yes. Because we can't, if we plug it, we're saying that x, because we could plug in 2. Okay, yeah. Does that make sense? We could plug in anything. Yeah, instead of x, if we plugged in 0, that would be okay up here, but you see how on the bottom it'd make it 0. But if we plug in 2, that's totally fine, because that doesn't make the bottom 0. Yeah, good question. Okay, so now we can simplify it. So we would have x over x becomes 1 over 1, correct? And it was multiplication, so couldn't we divide this out, guys? And then there's a 2 on top, anything on bottom? Nope. So left on top was 2 times 1, which is 2. And on bottom we have 1 times x plus 1. So this is our answer as long as x does not equal 0 and x does not equal negative 1. This would be how we would write our final answer. Everybody good? First step. Yes. Yes, only because here's why if you simplified first. You would look at this and then just say x cannot equal negative 1, which is true, but you'd be missing the 0. Does that make sense? So that is a great question. That's why we have to restrict the domain first, because sometimes those bottoms will divide out, but they were there originally. Does that make sense, everybody? Okay, let's just start doing some examples off the worksheet. So we're going to be kind of all over the place. So go to your worksheet. If it says worksheet, I'll tell you either page 1 or page 2. So this is page 1. This is the front of your worksheet, the white page. Here we go. So here's some examples. It says simplify each expression, state any excluded values. So we need to factor the top, factor the bottom, and then we can divide out exact factors after we exclude the values. So on top, what do we factor out? 6. We'll want to factor it completely, so we want greatest common factor. So we factor out a 6, so then divide by 6, divide by 6. So left is p minus 6, correct? Everybody good? And that's all over 18. Okay, I don't need to factor out 6 further or 18 further. We can just divide. So let's look at the bottom of this fraction. Could 18 ever equal 0? There's no variable, right? Everybody, do you see how there is no variable here? So the bottom's never going to equal 0. So we can plug in anything in this function. We don't have an excluded value. All right, so let's simplify it. We have a 6 on top. It's being multiplied, so we can divide it out. 6 over 18 becomes 1 over 3. P minus 6. Can we divide 6 and 3? No, it's p minus 6 connected with a subtraction sign, so you can't do that. So left is our answer, p minus 6 times 1, which is p minus 6 over 3. There was no excluded values in this problem, so that's our final answer. Everybody good? Okay, let's do this one. It's all multiplication, sweet. So, oops, sorry. Didn't mean to put that. Well, I can't erase that. We'll erase it. So we have a 8 times b to the 5th, 64 times b to the 4th. Times multiplication, you can divide out. But let's restrict the domain first. So our bottom cannot equal 0. So, and it didn't factor really any further. So we could think of it like this though, right? Isn't that 64 B, 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 B? 1, 2, 3, 4 B's. So when will this equal 0? If B equals what? What's negative 64 times 64? Is that 0? No. What's negative 64 times 64? Some big number, right? Which is fine. That's totally fine. The only time there's a problem is if the bottom equals 0. So isn't it when B equals 0, guys? 64 times 0 is the only time this is going to equal 0, correct, everybody? We all see it. So B cannot equal 0. Because that's 64 times 0 times 0 times 0 times 0. Everybody see it? Okay, so now we've restricted that. So now that will be our restricted value, which will be in our final answer. Now we can simplify. 8 over 64 becomes 1 over 8, right, guys? And then we have a b to the 5th on top divided by b to the 4th. What is it? B, and that's b where? On top or bottom? Top. So we have a b, and then that's gone. So that's 1 times b on top, which is b. And on bottom, we have 8 times nothing. 8 times 1, technically, so we just have 8. Correct? That's our answer as long as b does not equal 0. Everybody good? Let's do some more. Number 2. Fix this. Notice yours has a typo. It just says q plus 4q. Those are like terms that would be combined. It's supposed to be q squared plus 4q. So this is still on page number 1. Look at problem 2. Fix it. All right, so we have q plus 1 on top. And we're going to factor it. So we know that's how we can actually simplify this. Because we have to divide out exact factors. You don't know if you have exact factors unless you factor it. So left on top is q plus 1. There's no simplification. Does everybody understand? Let's factor the bottom. It's a quadratic. We have to say, I know how to factor a quadratic. What multiplies to be a times c. What multiplies to be 3 and adds up to be 4. 1 and 3, can we quick factor it? Yeah, so let's do that. The bottom factors to be q plus 1, because it's positive 1. And then it factors to be q plus 3. Most important, restrict the domain before you simplify. That is one of the most common errors I see people do. So on bottom, we know that the bottom cannot equal 0. So when will each of these equal 0? Well, if you don't know, set them equal to 0 and solve. So subtract 1, so q cannot equal negative 1, correct? Because that would make this undefined. We subtract 3, so q can also not equal negative 3. That would make the bottom 0 as well. Everybody good with that? Does everybody understand why? Okay, so now we can divide out exact factors. We have a q plus 1 on top. Do we have that exact thing on bottom? Do they just divide away and become nothing? No, they become 1s. That's another common mistake. So on top we have a 1 left. On bottom we have a 1 times q plus 3, which is just q plus 3. So that's our answer as long as q does not equal negative 1 or negative 3. Pretty simple, right? I mean, for the most part. If you can factor, you can do this. If you don't make any common errors, then it's pretty easy. No, whatever the bottom cannot equal, just set it equal to 0 on bottom. So as you're saying, is this always positive? These ones are negative. They could be positive. It just depends on what the bottom factors could be. It's just when the bottom could equal 0. That's a good question. Okay, let's do this one. Number 4. It says simplify each expression, state any excluded values. So you have to make sure you don't do something weird here and go, oh, x over x divides out and 1 over 1. Isn't there an addition and subtraction? This is not properties of exponents then. You can't just start dividing out things. You have to have exact factors because there's an addition sign and subtraction sign. So let's factor it. On top, x plus 1 doesn't factor. On bottom, we'd say, okay, it's a quadratic, and we have a middle value of 0. So we're doing what multiplies to be a times c, which is negative 1, and adds up to be b. Notice there's no b value, it's 0. So what multiplies to be 1, guys? 1 times 1? Negative 1 times 1 is negative 1, and isn't negative 1 plus 1 0? So we'd say, okay, can we quick factor it? Yes, a value is 1. So this bottom's going to factor to be x minus 1 times x plus 1. Before you divide anything out, you've got to restrict the domain because this is the original polynomial. It's just in factored form. So we'd say, okay, the problem is when the bottom equals 0, only the bottom. So we'd say x minus 1 equals 0, set x plus 1 equal to 0, and solve for when those values will be 0. Add 1. So x cannot equal 1, correct? Because that would make the bottom 0. Subtract 1. X cannot equal negative 1. Does everybody understand? If I plug in negative 1 right there, it's going to be 0. 0 times anything is 0. Everybody good? Okay, now we can simplify it. We have x plus 1 on top, x plus 1 on bottom. That's 1 over 1. So in our final answer, there's a 1 on top, on bottom, x minus 1. That's our answer as long as x does not equal 1 or negative 1, because if that's true, if it does equal 1 or negative 1, that's not our answer if the answer is undefined. Everybody good? Okay. So, we're almost there, and then I'll just let you practice for a while. These just come with practice. So on top, simplify each expression. So there's a lot of things we could do here, but we want to factor out the greatest common factor. So what I would see is, does 56 divide by 14? If not, go to the largest factor of 14. Does that make sense? And see if they both divide by that. They both divide by 14? Okay, so let's pull out a 14. So then divide by 14, and we're not going to make any weird errors here. What's 56 divided by 14? Okay, so we have 4c left. And then right here, don't say that's nothing. Do not, at this point, you should not be saying that's nothing. What should you be saying that is? Minus 1. Very good. And on bottom, the greatest thing in common is a 6, correct? So then we'll pull out a 6, divide by 6, divide by 6. So left is 4c minus 1. Everybody good? Before you divide anything out, you've got to restrict the domain. So you look at the bottom and say, when would the bottom equal 0? Now careful here, this is where people get confused. We have a 6 and a 4c minus 1. Is there any variable on 6? No. So that piece will never equal 0. Does everybody understand? So there's no problem there. Our only problem is here. When does 4c minus 1 equal 0? Solve for c algebraically. We'd add 1. 4c equals 1. Divide by 4. So c cannot equal 1/4. That is our restricted value. Now we can divide out exact factors. Multiplication can be divided. 14 over 6 simplifies to be what exactly? They both divide by 2. Perfect. So that was 7 and 3. Very good. And then 4c minus 1 over 4c minus 1 is 1 over 1. So our answer is 7 times 1, which is 7. On bottom, we have a 3 times 1, which is 3. That's our answer as long as c does not equal 1/4. Everybody good? Okay. Now I want to just say something. If this would have been 6c, for example, right there, that has a variable. So that would have been 0, also 0. So everybody good? C could not also equal 0. Okay, last one. Then I'm going to let you practice. Here we go. So on top on this, actually, you guys go for it. Try this one. Top, you said, okay, the top in common had a 3, so then left was b minus 2. On bottom, you factor this. It's quadratic. What multiplies to be negative 4 adds up to be 0, which is 2 times negative 2. So then we can quick factor it. So it factored to be b minus 2, b plus 2, right? So then you were able to say, I like what I was seeing out there. You didn't divide those out and then restrict the domain. You did it first. So b cannot equal 2 and b cannot equal negative 2, because that would make the bottom 0. Then you did b minus 2 over b minus 2 is 1 over 1. So your answer was 3 over b plus 2, which you were right as long as b does not equal 2 or negative 2. You guys got it. Awesome. So what I want you to do is switch over to the notes, because I want to start out with a little bit about that level. So what you're going to do is 2a, 2b, 2c, 2d, 2e. Check them with me. Okay, so with this one, it didn't simplify, so that is our answer as long as x does not equal 5. Correct, everybody? This one is multiplication, and so we can simplify it. That becomes a 3 over 1, yeah? 3 over 1. And then a squared over a cubed is an a on bottom. So our answer was 3 over a. I better look at the bottom, 7a, which is 7a cubed, so a cannot equal 0. This is our answer. You all got that for number 2b, yeah? Because I feel like we were all that far. On top, nothing factors. On bottom, what do we factor out? Pull out a 3, so then what was left? Divide by 3, divided by 3. I heard somebody saying it over here. Okay, 2n minus 3, very good, tie. So then now we will restrict the domain, restrict the bottom. When could the bottom equal 0? Set that equal to 0 and solve. 3 doesn't have a variable, so we don't have to worry about the 3. So when it be 3/2, n cannot equal 3/2, and then those divide out. So that's 1/3 as long as n does not equal 3/2. Any questions up to here? 2D, we would factor the top, factor the bottom. I'm going to come below here. What's uncommon up here? 3 and an x, correct everybody? Are we all following? So then what's left in parentheses? Divide by 3x, divide by 3x. X minus 3, awesome. On bottom we have x minus 3. We're not going to make the sad mistake of dividing things out before we restrict the domain. So we know that x cannot equal 3. That's when the bottom equals 0. Now we divide those out to become 1s. So 3x is our answer as long as x does not equal 3. I'm going to put a comma to separate those because that kind of looks combined. Okay, 2e. A lot of people got it already. So what is the top factor to be? So, but make sure you don't say just x minus 2, right? It's 3. We pull out a 3, and then left was x minus 2. Does everybody understand? On bottom, you'd say, I know how to factor that. It's a quadratic. We've been focusing so much on that. We'll multiply to be a times c. We'll multiply to be -6 and adds up to be 1. 3 times 2, -2, +3, right? Can we quick factor it? Yep. So it'll factor to be x plus 3 and x minus 2. Now we restrict the domain. X cannot equal 2 or -3, right? And then those divide out to become 1s. So our answer is 3 over x plus 3 as long as x does not equal 2 or -3. So you guys are getting it. We're getting it. You're doing good. I'm feeling good about this. So go ahead and go back to the worksheet, your student worksheet, and do problem 7 to the front. We're starting on the front again. So do number 7 now. Okay, we gotta go through it at this point. On top, you guys tell me, what did that factor to be? X. Guys, on the top, what did it factor to be? X minus 12 and x plus 12. On bottom, just focusing on that, what did it factor to be? What'd you do? You pull out a 3x, so then left was x minus 12. How many of you were able to get that far? Now you restrict, okay, good. Now you restrict the bottom. When does the bottom equal 0? If x equals 0, correct? 3 times 0 is 0. So x cannot equal 0, or if I plug in 12, right here would be a problem. 12 minus 12 is 0. So x cannot equal 0 or 12. Notice there's 2 restrictions, it's degree 2, which makes sense. Aren't we just solving the bottom? Okay. And then, so now we can divide out exact factors. Those become 1s. So left on top was 1 times x plus 12. And on bottom, 3x times 1, which is 3x. So there's our answer as long as x does not equal 0 or 12. Okay, let's try number 8. Ready, set, go. If you've already got it and I checked you off, go. Keep going. You're doing good. Try number 8. This one real quick. You need to watch because this one's very interesting. So looking at 2f, go back to the notes. You have to understand something really important, and this is something you will see many times. You see how so we know how to simplify. We factor the top, x minus 3 doesn't factor. We factor the bottom. Now understand, do you see how the bottom is not in standard form? Highest degree to lowest degree. This is actually going to simplify, you just can't see it because it's not written in standard form. So let's rewrite this correctly in standard form. Isn't that -x and +3? Now I've just reordered it. Does everybody understand? So now I'm going to factor it. On top, still doesn't factor. On bottom, isn't the rule if we have a negative in front, only in front, we factor out a -1. Let's do that then. Let's pull out -1. So divide each term by -1. So then left would be x, and then +3 divided by -1 is -3. Everybody see what happened there? So now don't you see that there actually was exact factors? But Those divide out to be, oh, we better say x cannot equal what? 3. Okay, now let's simplify. Those divide out to become 1. What's 1 over negative 1? Negative 1, right, guys? So negative 1 is our answer as long as x does not equal 3. You've got to reorder things in standard form in order to factor them correctly. So let's look at 2g. Do you see how the top is not written in standard form? Let's rewrite it. Correctly, though, that's negative x squared, and that's positive 4. And on bottom, it's good, 7x minus 14. Okay, now let's factor the top. Well, the first thing I'm going to notice is there's a negative in front. That's the first thing I'm going to do is factor out a negative 1. So factor out negative 1, divide by negative 1. So that's positive x squared minus 4, correct? Minus 4 now? Is everybody seeing what's happening here? And then let's factor the bottom. Well, we got to keep factoring the top. So, but anyways, let's factor the bottom. Pull out a 7. Left is x minus 2, correct? Guys, we're all good? Can we factor this particular quadratic even more? Yes, but multiplies to be negative 4 and adds up to be 0. 2 times negative 2. So we would say, okay, we have a negative 1. And we also have that factors to be x minus 2 times x plus 2. And on bottom, we've already factored it to be 7 and x minus 2. Now we'll restrict our domain. So it's when the bottom equals 0. 7 doesn't have a variable, so we don't have to worry about 7. X cannot equal 2, because that would make this piece 0 right here. Okay, now let's divide out exact factors. X minus 2 is 1 over 1. So nothing else to divide out. So here's one thing I want you to understand. Anytime you have a negative 1, they'll just put the negative in front. So that's negative. And then we have an x plus 2 left on top. And on bottom, we have just a 7. Does everybody understand? That's our answer as long as x does not equal 2. Everybody good? Okay, so go ahead and try 2h. Look at the bottom. You would need to reorder that. So you tell me, what is your top factor to be? Okay, were we all able to at least factor that piece? And then what did you do to the bottom? I'm going to go over here. You standard form, so negative y plus 4. So what did that factor to be? Negative 1 parentheses y minus 4. Okay, very good. Now you would say to restrict the domain, the bottom cannot equal 0. So y cannot equal positive 4, correct? Divide out y minus 4, y minus 4. So I saw a few people write their answer like this, y plus 4 over negative 1. That is correct. However, isn't anything divided by negative 1? Can't we divide each of those by negative 1? That's probably what I would want you to do, because anything divided by negative 1 technically can simplify. So that's the same thing as negative y minus 4, correct, everybody? So this would be how I would expect you to probably write it. That would be the 100% correct answer. Okay? All good? Okay. We're going to keep going because I feel like you understand that. So we're going to go back to the worksheet. From here on out, we'll be working on the worksheet. So go back to your worksheet. Number 10. Let's go through number 10. So on top, we're going to factor it. Notice it's cubic. Okay, well, first of all, you shouldn't even be looking at if it's cubic or not. The first thing we do with any type of polynomial is say what's the greatest common factor. So tell me, what is the greatest common factor? 7d. Okay, divide by 7d's. Divide by 7d. So then what is left? d squared plus 2, correct? On bottom, there's a 2d in common. So then divide by 2d. So then left is 3d minus 1. Okay, looking at this, we'll restrict our domain. So whenever the bottom could equal 0, isn't if d 0, 2 times 0 is 0, right? You understand. So d cannot equal 0. And also set 3d minus 1 equals 0 and solve. So wouldn't that be 1/3? Add 1, divide by 3, right? So d cannot equal 0 or 1/3. Now we can divide out exact factors. Multiplication, can be divided. 7 over 2 doesn't simplify, so 7 over 2, d over d becomes 1. D squared plus 2, does that factor any further? Well, it multiplies to be 2 and adds up to be 0. Anything? No. 1 and 1 multiply to be 1, right? No, we don't have anything. So we know this didn't factor further, so we're good. So d squared plus 2, nothing. That exact thing would have to be on bottom to divide out because of the addition sign, right? So we still have parentheses d squared plus 2 on top, and on bottom we still have 3d minus 1. That's our answer right there. So that's as simplified as it gets. Is everybody good with that? Okay, I feel like we're getting this. We're doing good. Looking at number 7 on worksheet page 2. Flip to the second page. Here we go. Like I said, we're all over the place because there's good examples in every piece. So let's factor this one. There's a good reason why I'm choosing to factor this one. What multiplies to the top is quadratic. Do you see how there's no greatest common factor? Everybody good with that? So we'd say what multiplies to be 8 times c. What multiplies to be 42. Isn't 7 times 6, 42? And adds up to be negative 23. So let's list out factors of 42. 1 times 42, 2 times 21. Aren't those the ones? Wouldn't they both have to be negative? Which works because that's positive 42, and that would add up to be negative 23. Now careful, because notice on top, we can't quick factor. We have to drop and break. So we would have, okay, we drop down our end terms, and then we break down our middle term. So we have 7n squared, we're just factoring it, but we have to go about it the long way. We drop down 6, we're rewriting negative 23 as negative 2n, and then minus 21n, right? Group the first two, group the second two. The greatest thing in common in the first group is n. So left is 7n minus 2. In this group, there's a negative 3 in common, right? Wouldn't we pull out a negative because of that negative? We should all be able to factor pretty well by now. That's why I'm going this fast. So we factor out negative 3, and left is divide by negative 3. Left is 7n minus 2. So we're good. We factor out 7n minus 2, and left is n minus 3. That was all just factoring the top. So I'm going to circle that just so I can remember that I need to come back to that. So now I'm going to do the work for the bottom in purple. So looking at it, how do we factor when we have 4 terms? Grouping. So group the first 2 terms, group the second 2 terms. What's the greatest thing in common in this group? 3n squared. So divide by 3n squared, divide by 3n squared. So left will be n plus 1. And then in common here is negative 27. So then left is n plus 1, right? So we factor out n plus 1, and left is 3n squared minus 2. Now we better see if that quadratic factors anymore, right? So just a lot to it. Is it minus 27? Awesome. So thanks for catching that error. So minus 27. So does that is factored completely? Is that factored completely? No. What could we factor? Well, there's going to be a lot here. We could do this 2 different ways. Let's do the easy way. Isn't there a 3 in common? Everybody following? We'll factor out a 3. Left is n squared minus 9, correct? Now doesn't that piece factor again? So wouldn't that factor to be what multiplies to be negative 9 and adds up to be 0? 3 times negative 3, right? So we have a 3. We have an n plus 3 and an n minus 3 from the n squared minus 9. And then we have this original n plus 1, correct? Now I factored it completely. Everybody good? That was on bottom. So now I'm going to erase and write what was on top. On top was this 7n minus 2 and n minus 3. If you have messy work, you're going to mess up. So do what I did. Do your work over here, factor this one, do your work over here, factor this one, and then put it in one problem, all factors. Okay, now let's restrict the domain. When could the bottom equal 0? N cannot equal for this piece. What? What about for this piece? 3. What about for this piece? What about that? Nothing, right? No variable, so it's not 0. Does that make sense? If there was a variable there. Okay, good thought though. That's what a lot of people do. So on top, 7n minus 2, there's nothing on bottom. We have n minus 3 on top and on bottom. That's all it divides out, right? So our answer is 7n minus 2 over, leave your answers factored. We have 3, n plus 3, and n plus 1. Leave it factored. That's great. This is our final answer. Everybody good? Okay. Okay. Last thing, and then I'll tell you what's going to be considered homework. Last one. So everybody look at 13 on worksheet page 1. Flip back to page 1. This is a really good question to see if you know how to do what we just learned and actually how to put it in a real world problem. So let's read this. It says, the length of a rectangle is 3h plus 2. So I'm going to write down what I know. Length is 3h plus 2. And the width, so my width is 9h plus 6. It says, what is the ratio of length to width? So ratio means division. It says length to width. So length over width. So we have 3h plus 2 over 9h plus 6, right? And then we would know how to simplify that. Because we'd say, okay, now it's just simplify, which we know how to simplify rationals, factor the top, factor the bottom, divide out exact factors, right? So everybody see how easy that was, okay? So, what if I change this and said this instead? Okay, what if I would have given you something, if I would have given you an area and a length, and then I said find the width? Don't we know area is length times width? So let's say I said to you, the area of something is x squared plus 2x. What do you put that in for area? Do you get what I'm saying? And if I said, and the length is x plus 2. And then I said to you, what's the width? So you plug in for length, and what's the width? We don't know what the width is, correct? So how would we solve for width? Divide by x plus 2. So let's simplify that. Don't we simplify that by factoring out the top? Do you get what I'm saying, guys? So we factor the top, so then left is x plus 2. On bottom we have x plus 2. So isn't our width x? Everybody see how to do that, okay? All right, so awesome. This is what's required. So you have to do 14 through 17, so circle out on page 1. This is of your worksheet. So 14 through 17 and 19. Circle those right now so you know exactly what to do. So we've already done the first few, like 1 through 6. So what's required as homework is 14 through 17 if you haven't finished those, and 19 on page 1. Now go to page 2, which is the blue one. You've got to finish that completely. You've got to do this because you've got to have plenty of practice with this, because this is literally the last step. The rest of the unit, this is our last step. We do all this other stuff, and then our last step is simplifying the rational. So if you can't do this, you're going to fail every single problem. So that's why there's so much practice. So I'm doing this instead of online homework. I'm not going to do online homework this time because we're doing this instead. So you have a couple minutes. You could start a few of those.